Okay, let's do exercise number 2. Oh, actually, not all of my slides like this, but some of them, yes. I have question 1a. This is for you. It's supposed to be independently or independently? Independently, like on your own. Okay, I can correct this. Okay, this is the same idea. You see the product and you can apply the same method that we just did. This is the integral for you, integral for you, integral for you. And then we will do just this one. Exercise number 2. I have 5 different integrals, okay? And for each of them, it's a couple of integrals for you to practice. That means the integrals that we skipped, they are almost identical like exercise number 1. If you really practice, if you really solved independently or independently, you will be good. You will be like a master. Okay, let's look at this one. We have 5 to solve. This is the second one. Okay, we have integral of natural log of x dx. That means, first of all, what is the problem? If we would like to use integration by parts, we just have one part. We have just one factor. We don't see the product. Correct? That's what we will do. U substitution doesn't work. Yes, that we have to think what is available to us, what tools we have. U substitution doesn't work. The other method that we just learned is the integration by parts. Then we have to try integration by parts. And actually, yes, we will force it. We will multiply by 1. I mean, I'm not changing anything, but I kind of create that part, extra part. 1 times natural log of x. Okay, that's we have 1 and natural log of x. And we will try integration by parts. U and dv. Okay, and please tell me, how shall I distribute them? I think I have to put natural log of x and 1 dx. Because let's think, if I will put the other way, if I will let u to be 1, and if I will let dv to be ln of x, how I can recover v? I have to anti-differentiate, which is actually our original question, right? But if we can see, we have a 50-50 chance. If you set up them differently, like let's say wrongly, you will realize right away that something is wrong. Then always switch. Okay. So we have this. Now let's try to find derivative of natural log of x. Yes, I see 1 over x dx. And what about the antiderivative for 1? I see. Thank you. Beautiful attendance. And I mean participation. Attendance is also good. Okay. And now a blue formula, uv minus integral of v du. uv minus integral of v du. Yes, and let's see what we got. X ln of x minus integral of x times 1 over x dx. So nice. Integral of 1. X ln of x. And what's the integral of 1? Actually, again, the same exercise. Yes, x plus the constant. Again, it's really nice. And it's funny, when we take this function in the box, when we differentiate, what's the derivative? What is the derivative without working? Don't calculate, just think. What's the derivative of x ln of x minus x plus any constant? Yes, the derivative is natural log of x, because and yes, we know. Okay, that means this is integral of natural log of x. Now we can do it. Okay, and then I have exercise for you, the same concept. We have to force the product of two numbers, arcsine of x, arctangent of x, and just logarithmic function. You can try. Everything is solved for you on Canvas. Okay, you can see my solutions, but check after your solution. Don't check before. Okay, exercise number 3. Integral of t squared e to the t dt. Definitely product, correct? And do you think u substitution will work? When the u substitution will work? Who can tell me? For instance, if I will put cube, t cube. Yes, if I will put t cube, then it's the composition, yeah, it's the inner function. Derivative of t cube is t squared with some constant. Yeah, then we can, but no, let me remove that. We don't have it. Okay. Integration by parts. Integration by parts. U, du, dv, and v. Okay. The first row, how we can distribute. I have lots of helpers, which I love it. Okay, you suggesting t squared and e to the t. Yeah, I think it's good because again, if you do the other way, you will realize that something is like, it's going not in the right direction. One thing you can see, t squared, when I differentiate, I minimize, yeah, the degree. When I will put t squared here, then we will have integral of t squared is t cube over 3. That's we will probably make it like more complicated. Yeah, depends, not always. Okay, that means this is good. That's important part. That's the art. That's the more expensive part. Now it's the work. Okay, derivative of t squared is 2t dt. Perfect. Integral of e to the t is e to the t. And the blue formula, uv v du. uv minus integral of v du. Okay, let's see. E to the t, t squared, minus integral of 2t, e to the t dt. E to the t, t squared, minus 2t, e to the t. And actually, what happened? What about this integral? Is easy to integrate? Yes, I think we still see the product, t e to the t. I can even put the product. And I think we have to use the integration by parts, like the second time. That means this exercise is showing you that we may apply the rule multiple times. Okay, integration by parts, but now we're looking at this one. Okay, u, du, dv, and v. Beautiful solution. And we will be, since we put the algebraic function t squared for the first one, I will put t. Then when we're applying like a second time, the third time, let's be consistent with the type of the functions that we choose for the u and dv. And this will stay e to the t. Okay, and then 1 dt or t, e to the t. Okay, and the same formula, uv minus integral of v du. I can maybe write the formula, uv minus integral of v du. We have to be careful because we see that we have -2 affecting the formula of the integration by parts. As we can see, we have to distribute that -2. Okay, let's try t squared. And what we have? We have e to the t times t minus integral of just e to the t. E to the t, t squared, minus 2 e to the t, t, and maybe I can speed up. Negative times negative is positive 2, and integral of e to the t is e to the t. I hope that's okay. Okay. Okay, that's we can see this exercise number 3 is telling us that we may apply a couple of times. Yeah? Each exercise is fun. Okay, what else? Exercise number, oh no. 3A, 3B, 3, oh, okay, just 2. The same idea, okay? The same idea like the, like number 3, okay? And probably you have to apply a couple of times. No. Oh, Lily, you think you forgot like everything. It's just the beginning of the semester. If you think, yes, because probably you're not the only one. If you think that you completely lost, try to look at the solutions and maybe just like copy the solution or like repeat what you just saw, and then do a couple of times, and then take, like, for instance, the fresh example and try to do on your own. Okay. If you look at the videos, the YouTube videos, I think on the top, I have the link to some of my Math 140, the Calculus 1 videos. That means maybe you can revisit some of them if you need some extra help. If you need the notes, maybe I can also post the notes from Calculus 1. Yeah, but I don't want to give you like a lot, because then we will be lost and we will be not focusing on calculus 2. But I can try to put some review notes. Okay. Okay, I know that everything will be good. Okay, exercise number 4. Now, each exercise, it has different style, it's different kind. Okay, evaluate the integral natural log of x over root x dx. What about integral like this? Natural log of x over x. How would you solve this one? Natural log of x over x. Use substitution, because 1 over x is the derivative, nice. But this is not x, it's something else, square root of x. Yes, that was my first question. First of all, we see a quotient. We have to see a product. That means I will rewrite as a natural log of x times this, or even like this. Okay, we don't really have functions square root 1 over square root of x. That's the important difference. Okay, we see the product now. We may try integration by parts because we don't have any other options. U and dv. We will calculate du and we will recover v. Okay, that's in what is the distribution. Yes, we have to do natural log of x because we know the derivative. We don't know the antiderivative unless we check exercise number 2. Okay, sometimes we will do this way. Okay, and please remember 1 over square root of x, not square root of x, because this is the common mistake, that we will grab square root of x. Okay, derivative is 1 over x dx. Oh, what about this one? We need antiderivative. Oh, I see 2 root x. Let's say this. 2x to the 1/2, because we still, either way is good. Yes, x to the power of 1/2. Okay, and the formula is uv v du. uv integral of v du. Okay, and let's see. 2 square root of x, natural log of x, I can do square root of x here, minus 2 x to the power of 1/2 times 1 over x dx. Let's simplify. Actually, I can do square root of x, but we have to simplify this anyway. It will be x to the power of what number? If we have 1/2 and 1. X to the power of 1/2 divided by x to the power of 1, we will subtract the exponents. 1 minus 1/2 is -1/2. Okay, and let's do the final step because integral is easy. Integral of x to the -1/2, again, is the same exercise. 2 root x, which will be 4. 2 times 2. Okay. Also nice integral. But we can see this one is, I can maybe use, please notice that we're using not square root of x, we're using 1/. Okay? Because we have to see the product. Okay, and then I have for you, and okay, just 2. Okay, and then I have the last one. I mean, we will still solve a couple of integration by parts with the limits of integration, okay? Okay, but the last one, the last type. Something, yes, something different. We will see. E to the x times sine of x. We have product, no problem. Yes, no problem at all. Okay. Yeah, can we just apply the integration by parts? I think we don't. Yeah, because no problem, no tricky part with the quotient, no tricky part with like not having a product. We will see what's happened. Okay, u dv, and then we will calculate du, and we will recover v. Okay, and then we have e to the x sine of x. I see Tongler, yes, I think because always it's easier maybe to anti-differentiate e to the x. And I think it's easier to differentiate trigonometrics. Yes, we're more confident with the derivatives of the trigonometrics. I think in this situation, it will work if we will do the other way. I believe so, but okay, let's see. You can try the other way after the session. Okay, let's see. Yes, du is cosine of x, dx, and this is just e to the x, easy. Oh no, let's pick blue. Let's be consistent. uv, v du. uv minus integral of v du. uv, v du. Okay, and what we have? E to the x sine of x minus integral of e to the x cosine of x dx. Oh, wow. What we have to do? E to the x cosine of x. Again, integration by parts. Okay, u, du, dv, and v. And we will be consistent. Since this was trigonometric, I will also put this way. Okay. Please help me. Derivative of cosine is negative sine of x. I said we are more confident. I think we are. E to the x. Okay. And the new formula. uv, v du. uv, integral of v du. We have to be careful because we have negative in front. E to the x sine of x minus e to the x sine of x minus, and now e to the x cosine of x minus integral of e to the x, and it's actually minus, let me put plus if that's okay. Because it was negative and subtracting negative is positive. I will just distribute negative. And what do we see? This will be negative because of that. actually, what do we see? E to the x sine of x dx. We did integration by parts twice. And we got, yes, we actually, but what we see the same original integral. We didn't really went like far with this. Okay, we kind of get back. Displacement is 0. we get back to the original point. That's in what first of all, you probably notice that it's no point to actually apply the integration by parts again and again, because it will be a loop. That's what I will do. Because I will create an equation. Equation is just left-hand side, right-hand side, and the equal sign. Yeah, normally we're not really creating an equation, because that's what we end up having, right? That integral equals to this. Yes. And if we think in this boxed equation, yes, I did create because normally what we're doing, we have an integral equals to, and it's first step, second step. It's not an equation. We don't really have left or the right-hand side. But what I did create an equation. Okay, that means just an equation is as simple as it is. Left and the right-hand side and the equal sign. And we notice that in this equation, we have only one unknown. Do you see this? We have this integral, which is identical. Let's call it I. Let's call it I. And then how the equation looks like. I, e to the x, sine of x, e to the x, cosine of x, minus I. Can we solve it for I? That will be the integral. Let's add I to both sides. Oh, I can factor out e to the x, but let's divide by 2. That means integral I equals to 1/2 e to the x, sine of x, e to the x, cosine of x, and we can put plus the constancy. And that's actually the integral. Okay, how can I indicate this? Yes, this is I. That's the integral. That means this will be that one crucial step, creating an equation and solving for this unknown, the same integral on both sides. Okay, it's a nice integral maybe for the tests. I don't know. Yes, it's nice. It's different. Yes, it's unique. Definitely for the homework assignment, because it's a little bit time consuming, but it's still, yes, nice. Okay, that means that's the only types that you can see. Yes, you can multiply by 1 to force the product. You can apply a couple of times integration by parts. What else was? Or you can have this type of integration by parts, that you will end up having a loop of the same integral, and then you will stop, of course, and create an equation. Okay, and the first one was just a regular, no problem, product, integration by parts, and done. Yeah, that's all of the types. Okay, what I have this slide. Oh, that's for you. That's the equation type. And that's it. Okay. That's I was thinking about these notes. I just listed typical types for the integration by parts, the typical types of the integrand to apply integration by parts. That's what we may notice is like algebraic function, exponential trigonometric, algebraic and logarithmic, and just inverse. You will probably do the times 1. Okay, and now I also list the type. We see inverse function, we see logarithmic, we see algebraic. Algebraic are the power functions. Trigonometric, exponential. And when I take only the first letters, yes, you can create, I don't know if it's common word, frequent word, not really, I late, I latte, I don't know. whichever way you will read this, you may try to remember this, because whichever letter is on the top, I mean the top function, whichever letter is the first one, is easier to get this setup, choosing for you this function. Whichever is at the bottom, it's easier to be dv, the derivative, because the bottom functions are easier to be anti-differentiating. Exponential, trigonometric, yes, algebraic, logarithmic are not that easy to be anti-differentiating, but they are easier to find the derivative. That's when maybe you can remember this. Just a small suggestion to memorize. Okay, and now as promised, let's maybe solve 1 or 2 integrals, and then I can let you go with limits of integration. That's basically what we have to do. We can follow the same rules and just apply the limits of integration for this part and apply the limits of integration for this. The good thing is we're not changing any variables. That's we're not changing the limits of integration. They will stay the same. Because for the U substitution, we're actually changing the variables, then we have to change the limits of integration. This one will stay the same. Or you can even find the final answer and apply the limits of integration. Okay, that's me. Now let's see. Yeah, let's do this one. It's a nice actually integral. Integral of arctangent of x dx from 0 to 1. Which actually will represent the area of that golden region. Okay, please tell me what I have to do, and I will do it. Yes, we just see the inverse, we will force it, we will multiply by 1. Okay, integration by parts, yes, and then u, du, and dv, and v. Okay, u is, of course, arctangent, no other option. And this will be 1 dx. This is x. Oh, I see you helping me. Good, good, good. Derivative of arctangent of x is 1 over the quantity 1 plus x squared dx. Okay, and the formula is uv v du. Let's say uv integral of v du. Okay. Okay, let's do this one. That's what it will be x arc. Now, let's maybe do here, because we will need maybe more room. X arc tangent of x minus integral of x times 1 over 1 plus x squared dx. This will be evaluated from 0 to 1, and also this one. Okay, what about this integral? Do we know what to use? It's a variable on the top. That's it will be the u substitution. Yes, it will be the u substitution. Arctangent of x. I can copy this. And when I will let u to be 1 plus x squared 2x dx. That's we will have extra 1/2. Extra 1/2 x dx. It will be 1/2 1 over u du. But we can say 1/2 natural log of u. And natural log, let's come back to this one. Okay, because you can see I just said we don't have to change the limits of integration, but this was different. This was like additional u substitution, wasn't the main. That means I did come back, and then I can say that I am evaluating everything. Okay, that's what let's say this one is natural log. Let's copy this to have a beautiful solution. Okay, that means now I have entire antiderivative, and we can apply the limits. Yes, 1/2 natural log of 1 plus x squared. Really good. Okay, let's substitute 1 really quickly. You can help me. 1 arctangent of 1 minus 1/2 natural log of 1 plus 1, 2. And then 0, arctangent of 0 is 0, 1/2 natural log 1 plus, it's actually also 0. Yes, because natural log at 1 is 0. Arctangent of 1, yes, pi over 4. And this one we can leave it, natural log of 2 over 2. Okay, really nice. Yes, nice answer. And the value must be positive because we can see it's above the x-axis. Yes, yeah, really nice integral. This integral is really nice. And it's good for the exam. It's good because includes a couple of concepts. Okay, shall we do one more? What else I have? Just one more. I have this one, but this one I think it's also on the list for you. I can leave it this one. This one is too easy. This one is nice. Shall we do this one? Oh, this one is, oh, we just did arctangent. Probably it will be extra. Yes, extra thing. You still have to multiply by 1 and do almost the same like we did the exercise like the last one. But it will be a couple of extra steps, but it will be easy, I think. Oh, and I have, oh, we can do this one. Oh, okay. Let's actually, because this will be good for your test. I always forgot about these tables, which I always like to create this on the test. Okay, that's it. Let's do C. Okay, because this one is the U substitution. You can do it, and this one is also U substitution. This one is not the U substitution. Let's try C. Okay. Okay. Integration by parts. That's we're not doing this. I mean, I don't want to cross it because you can try, but we will do C. Okay, how can I do it? Integration by parts. U, du, dv, and v. Okay, and we have x and we have second derivative. That means, oh, and we have second derivative. That's we have to put x and we have to put second derivative. Dx. Okay, this will be 1 and this will be first derivative. Yes, okay, really good, really good. And let's see what we're getting. UV, VDU. Oh, it's supposed to be blue, but it's okay. That's we will say UV integral of VDU. Oh, no, not erasing. Okay, that's we will have x, f prime of x minus integral of f prime of x dx. And what is integral of f prime of x dx? It's just f of x. That's nice. Okay, now I can hug everything and apply the limits of integration because we didn't change anything. Maybe here, 6 f prime of 6 minus f of 6 minus 2 f prime of 2 minus f of 2. Okay, please help me. 6 times, what is f prime of 6? F prime of 6 is -3, yes, thank you. And what is f of 6? F of 6 is 6, okay, minus 2 times f prime at 2. -2, yes, we have to be careful, minus f of 2. F of 2 is 13. Oh, wow, okay. What we have? We have -18 minus 6 minus -4 minus 13. Wow, so many negatives. -24 minus negative 17. Please watch me because I know negative 24 plus 17. 3 plus 4, 7, actually negative because it's negative 24. Yes, oh, I see, yes. Okay, I manage, yeah. But the whole integration is important, yes? I mean, everything is important, even the arithmetic. Okay, that's me. Let's finish. I think we covered this section beautifully, like everything. You can definitely, this presentation is a perfect source of lots of examples. Okay, make sure that you can solve independently. No. Okay, and next week we will do trigonometric substitution. Really nice, 7.3, and also 7.5, I think, partial fraction decomposition. 2 methods. One day, yes, one each per session. Okay, thank you and see you. Yes, see you next week. Thank you. Oh, and also just a quick, you may, because you will have the GSG leader running the review session, and I think he's asking about the time. Please respond on the announcement, like what will be the good time that you will eventually attend the session. Yeah, if you need extra help, please respond to him because I don't know. Yeah, I don't know if you see the announcement. Check the announcement, okay? Thank you and see you next week. Thank you. Oh, that means the announcement was set up incorrect. Okay, I will try to, okay. That's the reason that I didn't see any response. Okay, I will check that announcement. Oh, I didn't even think. Okay, I will check. Thank you for that comment. Thank you. Okay, I will just, yeah, I will check it now. Thank you. See you later. Thank you.